we're gonna do the tutorial sheet for today, right? So let me go to the share screen and show you this tutorial sheet. The tutorial sheet we're gonna do today is this one here. Just a minute. All right. This is the tutorial sheet we're going to do today, right? It has about, well, it has exactly how many? 7 questions, right? So I'll try to do as many as I can. I can't promise I can do all of them, but I will try. So let's start with question 1, which is this one, right? So let me stop share. If you have any question during the tutorial, if you have anything you want to ask me, just, as usual, feel free to use the chat room, right? Okay. So let's start with question 1. Question 1 is this one. This is the question. So you have this data set, and the question is to find the quartiles or quantiles at these levels: p equal to 0.1, 0.25, 0.5, 0.75, and 0.9, right? So let me show you how to do it. This is stuff we talked about a long time ago, you may recall. So to do this kind of question, you need to use the following formula, which I gave you a long time ago. I don't know whether you remember this, but if you don't remember, I will write down one more time, right? So this is the formula that I gave you some time ago. Can you read my writing, guys, or no? If you can't, let me know. I'll try to. Where do you remember this formula, guys? I gave you quite a few weeks ago. I mean, maybe 2 or 3 weeks ago, I gave you this formula, right? Okay, so this is the formula I'm gonna use today. Okay, I'm really disappointed with the number of people turning up for the tutorials. I really don't know why it's so small today. All right, the first thing, all right, we have n is a sample size, which is 25. And the first thing we want to find is the quantile at p equal to 0.1. So your R is gonna be p times n plus 1, which is 26. So this is gonna be 2.6, and your R prime is the integer part of 2.6, which is 2, right? So your Q at 0.1 will be all right. This is the formula. I'm just simply applying this formula here, right, and writing it down. And if you work this out, guys, I'm sure you are all, you know how to do it better than me. This is what you will get. So your Q at 0.1 is 0.75. The next one, we want to calculate the quantile at 0.25, which corresponds to the first quartile. All right, so your R will be 6.5, and your R prime, which is the integer part of 6.5, it is 6. Right? Your R prime will be 6. Okay. So if you apply this formula one more time, you will get Q it will be 6.5, sorry, 6.5 minus 6, right? And in brackets, you have x. Okay. Now, if you work this out, guys, you will get 2.1055, right? So this is the first quartile, or Q at 0.25, okay? All right, next, next is we want the quartile when p equal to 0.5, which corresponds to the median. So in this case, your p is half, all right, which is 0.5. So your r will be 0.5 times 26, which is 13. And r prime will also be 13 because the integer part of 13 is 13, right? All right, so you get Q, the median, to be equal to x13 plus 0, because remember r minus r prime, in this case, both are equal, so r minus r prime is 0, right? So this will be equal to, if you work it out, it is 2.89557, right? So that's the median, right? Or the quartile corresponding to p equal to 0.5, right? It's the median, as you know, right? All right, the next one. Any questions so far? Guys, please feel free to talk to me using the chat room, right? The next one is p equal to 0.75, which is the third quartile, right? So your r in this case is 0.75 times 26, which is 19.5. And your r prime is the integer part of 19.5, which is 19, right? All right, guys. All right, next, so if you use the formula that I mentioned just a second ago, this is what you will get. Q at 0.75 equal to x19 plus 19.5 minus 19. Okay, this is what you will get, right? And if you work this out, you will get this to be 6.15. So this is the third quartile, right? Or Q at 0.75. All right, the next one is, so n is 25. P, we want P to be equal to 0.9 in this case, right? So your R is 0.9 times 26, which is 23.4. And your R prime is the integer part of 23.4, which is 23. All right, so Q at 0.9 will be all right, times, in brackets, x 24 with the 24th largest observation minus the 23rd largest observation. All right, and if you work this out, this will be 14.53384. All right, so that kind of completes question one, but it's also asking you to comment on the distribution of the data. Now, if the data are symmetric, right, you would expect the distance from the first quartile to the median, right, or from the median to the first quartile, which is this one, right, to be equal to the distance from the third quartile to the median, which is this one, right? But for the data that we have, right, for the calculation that we just done, this guy here is equal to 0.7902, and this guy here is equal to 3.2453. So clearly there's a big difference between this and this, right? That is, in other words, the distance between the median and the first quartile is very different from the distance from the third quartile to the median. So what this implies is that the data are not symmetric, right? Are you guys okay with this or no? Hello guys, talk to me. Are you okay with this example? Example 1. We just finished doing example 1. Okay, thank you guys. All right, the next example I'm going to talk about is example 2, which is this one. Right, so you have the following data set. There are 20 data points. There are 4 parts. The first part is to complete the 5-number summary. Remember, the 5-number summary is something I talked about in the last tutorial. So this is question 2. The 5-number summary is the first one is the minimum, right? The minimum is the smallest data point, right? So the smallest data point in this over here is clearly equal to 29.140. All right, the second number is the first quartile. Now to find the first quartile, all right, your n is 20, you need to put p equal to 0.25. So your r will be 0.25 times n plus 1, which is 21. So this is 5.25, right? And your r prime is the integer part of this, which is 5. So your q at 0.25, which is the first quartile, is x. This denotes the 5th largest data. Then in brackets, you have x6 minus x5. Right, if you work this out, this will be 37.0325. Right, so this is the first quartile. The next thing we need to find is the median. So your n is 20 and your p is half. Okay, so your r is simply 0.5 times 21. It's gonna be 10.5, right? And your r prime, which is the integer part of this, is 10. Right, so your q at 0.5 will be x 10, right? Then in brackets you have x 11 minus x 10, right? And if you work this out, this will be 41.186. So this is the median of the data, right? The next number in the 5-number summary is the third quartile. So your p is 0.75. So your r will be 0.75 times n plus 1, which is 21. So this is 15.75, right? Okay, and excuse me. And your r prime is the integer part of this, which is 15, right? Okay, so your q at 0.75 will be x 15, the difference between 15.75 and 15, right? Multiplied by x, 16x 15. Sorry, why do you get 20? 21, so it's because n plus 1. The formula, if you look at the formula that I gave you in the class, this is the formula, Harvey. This is the formula where r is p times n plus 1. So if n is 20, n plus 1 is 21, so that's why I'm multiplying by 21 here, 21, 21, because it's n plus 1, the sample size plus 1, right? Okay, so if you compute this, you will get 44.01975. Is that clear, Harvey? Because your 21 is because n plus, I'm using the formula r p times n plus 1. All right, the last number, excuse me, the last number of the 5-number summary is the maximum. All right, this is the maximum. All right, so I've done the 3 numbers. All right, the three numbers in the, sorry, the 5 numbers. The first of the 5-number summary is this one. The second of the 5-number summary is this one. The third of the 5-number summary is this one, and the fourth is this one, and the fifth is this one. So these 5 numbers form the 5-number summary of the data. All right, guys. Okay. Any questions? So any other questions, guys? Or are you okay or not? Are you guys okay so far? Yeah. Okay. Thank you. All right. The next part of the question number 2 is to compute the sample mean and the sample standard deviation. So let's see how we can do this. All right, so this is question 2, part 2. So to compute the sample mean, all you have to do is just sum the numbers. So you sum all the numbers from this all the way up to the last number, which is this, and you divide by 20, right? And this is what you will get. Okay. Now, so this is the sample mean. To find the sample standard deviation, you will use this formula. This is a formula I gave you a long time back. You may recall, right? Okay, this is the formula. Now, this formula you can also, there's an equivalent formula for this, which is all right, this is an equivalent formula. This, I think I proved that these 2 formulas are equal. I gave you a proof of that in the class, right? All right, now if you compute this, your n is 20, so n minus 1 is 19. This is the sum of the squares of the data, so it will be right, and then you subtract n, which is 20, times the sample mean, which is 40.6942 squared, right? Okay, so if you do this, if you do the math for this, this is what you will get. You get 30.54325. Okay, so that's the sample variance. Now to find the sample standard deviation S is simply the square root of S squared. So it's the square root of 30.54325. And if you do this, you get 5.527. So this is the sample standard deviation. All right, so this completes part 2 of question 2. Now part 3 is to draw the histogram, right? Now I think I showed you how to do this. So let me the first thing you need to do is to draw a table, right? So this is question 2, part 3, right? So you need to define three columns. The first is the interval column, the second is the frequency column, and the third is the density column. Now the interval, in this case, we want the intervals to go from 25 to 55 in steps of 5, right? So the intervals are gonna be this, 25 to 30, right? 30 to 35, 35 to 40, 40 to 45, 45 to 50, and 50 to 55. So these are the intervals, right? And the next thing we want to do is to find how many of the data points fall in each of these intervals, right? And you can do that easily. So if you do that, this is what you will get. These are the number of data points in each interval. Now, to find the density column, I think I gave you this formula before. The density is defined by the frequency. It's defined as the frequency column divided by the number of data. The number of data multiplied by the interval width. Okay, so in this case, so the number of data is 20 in this case, and the interval width is 5. So 5 times 20 is 100, right? So this will be 1 over 100, 2 over 100, 5 over 100, 8 over 100, 3 over 100, and 1 over 100. All right. Okay, guys. So I've done the table. So this is the interval. These are the frequencies, and these are the densities. Now, you should draw the density plot, which I have already done. This is what you will get. So you see, on the y-axis, I have the density, and on the x-axis, I have the intervals, right? Now, the density column is that, as the name stands, the area beneath the density, right? You should compute it. This must be 1. This area, the area must be equal to 1. Right? So, I mean, as you know, for any probability distribution, the area below the density must be equal to 1. So once you plot this is the density column, this is the interval column. So once you plot them, the area, you should calculate the area of each of these rectangles. So this rectangle, this one, this one, this one, this one, this one, and sum them up, you will get the area to be equal to 1. Okay? You guys okay? Talk to me, guys. Are you okay so far? Right, so that's part 3 of question 2. Now part 4 of question 2 is this one, right? So let me show you how to do it. Part 4 of question 2 is to show whether, excuse me, it's question 2, part 4, right? Is to check whether the distribution is symmetric or not. Now remember what I told you a couple of minutes ago, right? That if data is symmetric, if data are symmetric, right, then the distance from the median to the first quartile, right, must be equal to the distance from the third quartile to the median, right? Okay. So in this case, for the data that we just considered, this distance is equal to, we should work it out, it's equal to 41.186 minus 37.0325. This is what you get. And this distance is equal to 44.01975 minus 41.186, right? Now, you should do the math. I mean, you should have a calculator in front of you. You can work this out, right? And these numbers are approximately equal, right? All right. So you can, I mean, you should, hence the distribution is approximately symmetric. Okay. All right, guys. So that completes question 2. Are you okay with this or no? Before I go to the next example, next question. Yeah, that's another way of checking symmetry. Yeah, if the mean and the median are equal, that is another way of checking that the data are symmetric or not. Yeah, you're right, Neil. Yeah, you can also do it like that. You can compute the mean, and you can compute the median and see if they are equal. Then that would tell you whether the distribution is symmetric or not. Yeah, you're right. Yeah. All right, so that completes question 2. Well, the next question I'm going to do is question 3. Question 3 is this one. This is the data you have. Hope you can see it. This is the data. And there are 2 parts to this question. So you have the intervals, you have the frequencies, and you have the percentages. The first part is the following. That is, for a histogram based on the tabulation given, these are of width 10, starting at 5, calculate the height of the density at 20 and 80, all right? All right, so this is question 3, part A. So the question here is to calculate the density at x equals to 20 and x equals to 80. Remember what I told you. The density, the formula for the density is this. It's the frequency divided by the number of data multiplied by the interval width. Okay. This is the formula that I just mentioned a couple of minutes ago, right? Right, now if x equal to 20, what is the frequency? Come on, guys. If x equal to 20 falls in this class, right, from 15 to 25, so the frequency is 142. So this is 142 divided by the total number of data is 500. 500 is the total number of data points, times the width of the interval. Each interval here has width 10, right? So this is 10. So the answer is 0.0284. Did you get what I said? I mean, it just simply, you find the frequency, you find the total number of data, you find the interval width, and then supplement. That's it. Now, when x is 80, the frequency is, all right, 80 falls in this interval from 75 to 85. I mean, I know you can't see this because it's blurred, but can you look at in your computer, look at the sheet in your computer, you will see this is the interval that contains 80 and it has frequency 6. All right, so it's gonna be 6 divided by 500 times 10, which is 0.0012. All right, so that's the answer to part A. Part B, all right, part B is this. Now consider the histogram based on intervals of length 20 starting at x equal to 5. Retabulate the data and then calculate the same thing as in part A, right? So what they're saying is that instead of having length equal to 10, they want length equal to 20. So basically, the table is going to look like this. Excuse me. The table is going to look like this. So you see what I'm doing. So every interval is from 5 to 25, then 25 to 45, 45 to 65, 65 to 85, and so on, right? So for x equal to 20, if x is 20, then using the formula that I just gave you here, the frequency is going to be, right, 20 falls in the first interval from 5 to 25. And the frequency is going to be the sum of these two guys, 83 plus 142, right? So it's going to be 83 plus 142, right, divided by the total number of data points plus the width of the interval is 20 now, not 10, because I'm combining these two intervals into one. So the length of the interval is 5 to 25, which is 20, right? Now, if you work this out, this will be 0.0225. Now, when x is 80, the density is going to be, all right, x is 80, it's going to fall in this interval here, right? I hope you can, I don't know. Can you please look at your tutorial sheet on your computer, right? So you should be able to see it better. So this this interval from 65 to 85 contains 80, right? And the frequency is 13 plus 6, right? So this is going to be 13 plus 6 divided by 500 times 20. So this will be 0.00115. Right. So as you can see, the increase in the length, increase in the width of the interval has not made much difference to the density values. So if you compare this one with this one, they are similar. Similarly, if you compare this one with this one, they are similar. All right. So the conclusion is the following: the density values have not changed. In other words, they are similar. They are similar for the two interval width. right? All right, so increasing the interval width from 10 to 20 has not changed the density values much, okay? All right, guys, so that's question 3 done. Are you any questions on this, guys? Please let me know. Are you okay with this? I mean, don't be shy. All right, guys. All right, that's question 3 done. All right, the next question I'm gonna do, I'm gonna skip question 4 because question 4 is outside the syllabus, right? So you can try, but I'm not gonna ask anything similar to question 4 in the exam, right? So I'm gonna move to question 5 now. This is question 5. Question 5 is this one. So you have the following data. There are 18 data points. There are 3 parts. The first part is to compute the 5-number summary and the interquartile range. All right, so let's see how we can do that. So here we are. So this is question 5, part 1. So remember, the 5-number summary is the minimum, first quartile, median, the third quartile, and the maximum, right? The minimum is simply the smallest data point. So if you look at this data and pick the smallest data, it's gonna be 31. All right, the next one is the first quartile, right? So your R is gonna be P times n plus 1, which is 19, right? And that's gonna be 4.75. And your R prime is the integer part of 4.75, which is 4. So your Q at 0.25 is, this is the formula. All right. Now, if you work this out, this will be 69.75. Right. So that's here. That's the first quartile. All right. Now the median. To find the median, you put P equal to half, right? 0.5. So your R is going to be 0.5 times n plus 1, which is this. So that's 99.5. And your R prime is the integer part of this, which is 9. So your Q at 0.5 is this, right? R minus R prime, which is 9.5 minus 9. Then in brackets, you have this minus this, right? All right, and if you compute this, you get this to be 78. So that's the median, right? The next thing is to find the third quartile. So you get, you put P equal to 0.75. So your R is gonna be 0.75 times 19, which is 14.25. Right, and your R prime is 14. So your Q at 0.75 will be this. Yeah. All right. This is a formula I gave you before. And if you work this out, this will be 87.25. And finally, the maximum or the largest value in the data is 94. All right, so we computed the five number summary. So just to summarize, this is the first number summary, the first number of the 5 numbers. This is the second of the 5 numbers, the third of the 5 numbers, the fourth, and the fifth of the 5 numbers, right? Right. So now to find the IQR, remember IQR, the interquartile range, is the difference between the third quartile and the first quartile, right? Yeah, I gave this definition to you some time ago, right? So if you take the difference, you will get this to be 17.5. All right, so that completes the first part of question 5. Now, the second part is to use the results in part 1 to produce a box plot and comment, right? So this is where your box plot comes in, right? Now, remember, do you guys remember what a box plot is? Yeah. This is what it will look like. I have already plotted it. So this is what it will look like. You should plot it. Now, let me show you what the different things are. I mean, it will be helpful to have the numbers ready here. Right. Oh, have I put it right way around? It should be like this, I think. Should be like this, sorry. Should be like this, guys. Okay. Right. The first thing is the middle line here. The middle line is the median, right? So it corresponds to, let me have it this way. Oh, sorry. Let me have it this way. Anyway, it doesn't matter. The middle line is the median. So this line here corresponds to the median that we just got, which is Q at 0.5, which was equal to 78, right? Okay. And this line here is the third quartile, right? Or in other words, Q at 0.75, which is, we computed it to be this, right? Okay, and this line here corresponds to the first quartile, which is Q at 0.25, which is equal to 69.75, right? Okay, guys. Right, now, all right, let me explain. Okay, this here is the lower adjacent. This is known as the lower, I think I explained this to you before. This is known as the lower adjacent. Okay, and this guy here is known as the upper adjacent. Okay. Now, before I come to these two, I need to compute the lower fence and the upper fence, right? Remember, the lower fence, to compute the lower fence, you need to the lower fence, let me explain where they are. The lower fence will be somewhere around here. This distance, right? You should take the distance of 1.5 times IQR, right, from the first quartile. Then this will give you what is known as the lower fence. This is the lower fence. And in this case, you will get the value, this value to be 43.5. Okay. And the upper fence is beyond the reach of it's beyond the page, actually. You can't, I didn't draw this very carefully, so excuse me for this. But this is the lower fence, right? The upper fence is beyond the page, actually. It may be somewhere here, I guess, right? This is the upper fence, right? Right, and this is the distance from this to the third quartile, right, which is this one, is again 1.5 times IQR, right? Okay, so the coordinate for the upper fence is, if you work it out, it will be 113.5. Okay, all right. So I know it looks kind of clumsy. The scale is wrong. What do you mean this? I think the scale is okay, but so this is the lower fence. This is the upper fence. So the upper fence is computed by adding 1.5 IQR to the third quartile, and the lower fence is computed by subtracting 1.5 IQR from the first quartile, right? All right, and the lower adjacent, which is this one, right, is the smallest data values. So the lower adjacent is the smallest data. Is the smallest data value that is greater than 43.5. Yeah, 43.5 is the lower fence, and the upper adjacent is the largest data. I'm sorry for the messy picture. The largest data that is less than the upper fence, right? Okay. So if you work out, the lower adjacent will be will be 63 somewhere, right? And the upper adjacent, which is this one, the upper adjacent will be 94 somewhere, right? Okay. Okay, I think you're right. I think there's something wrong with the scale of the y-axis. I think there's something. I think maybe I didn't do it correctly. I apologize for it. Okay, so but this is how it should be. I hope you followed what I'm talking about. All right. So this is the box plot is made up of 1, 2, 3, 4, 5, 6, 7 numbers, right? So this is the lower fence. This is the lower adjacent. This is the first quartile, the median, the third quartile, the upper adjacent, and the upper fence. All right. Okay. So I think if you look at the solutions, which I will post later this week, I think that will have the correct scaling. I think I messed up the scaling today. I apologize for that. Okay. All right, guys. Okay. All right. So that completes part two of question 5. Now, part 3 of question 5 is calculate the sample mean and the sample standard deviation, right? Now, before I go to, I know I'm running out of time now. Before I go to part 3, let me say a few words about part 2. Part 2, you should look at the box plot, which is not really that good. I mean, if you look at the box plot one more time, the median is approximately halfway between the first and the third quartile. So because of that, you may say that the distribution is approximately symmetric, because the median is halfway between the first and third quartiles. Okay. All right, so that's question 5 part 2. Question 5 part 3. Question 5 part 3 is asking you to compute the sample mean and the sample standard deviation. The sample mean is just simply sum all the numbers, right, and divide by 18. 18 is the total number of data points, so that's gonna be 75.06. And the sample standard deviation is simply use the formula that I gave you before, just a few minutes ago. I gave you this formula, you may recall. Okay. All right, now if you use this formula and work it out, this will be 16.54, right? And the median, which we have already worked out, is 78. All right, so is 78. So the sample, they are not exactly equal, but they are not too far. Okay, they're not. I mean, for a symmetric distribution, you would expect the sample mean and the sample median to be close. Part 3. All right, in part 3, compare the values of the same and comment on the discrepancy between the two. Yeah, the outliers. There are 2 outliers you might have noticed in the box plot. There are 2 outliers. There's one here. I think the other one has disappeared. But the reason that the sample mean is different from, well, is about 3 points away from the sample median is because of this outliers. So the mean is affected. The mean is significantly lower because of the outliers. The mean is affected by the outliers, but not the median. All right, and that explains why that these appear different, right? Without the outliers, these two would have been a lot closer. That is, the mean and the median would have been closer to each other, right? All right, so this completes question 5. I'm sorry I messed up the box plot. Maybe next tutorial I'll try to get it right. I think the scaling was not right in the box plot. Okay. But if you look at the solutions I will post on Thursday, you will see I have used the correct scaling in my solutions, the video solutions, right? Okay, guys. So, any questions? Sorry, I also did not complete all the questions. There are 2 more questions. There are 2 more questions in the sheet which I don't have time to complete today, but maybe in the next tutorial I will try to complete all of them. So you are welcome to come to the other tutorials this week. There's one this afternoon from 4 to 5 UK time. If you have time, you can attend that too. Okay. All right, guys. Any questions on the stuff I did today? Hello, you guys okay? Hello, guys. Are you okay? Are you okay with the stuff? Okay, thank you, guys. So have a great afternoon or evening. I will talk to you guys later, later today or next, later this week. All right. All right. Take care.